So for this first one, we have this graph, and we need to find whether it's concave up or down or both from 42 to 44. Well, this goes from 0 to 4, so that means if this continues, our next one would go 4, 5, 6, 7 to 8. So our next one would go 8 to 12. 12 to 16, 16 to 20, 20 to 24, 24 to 28, 28 to 32, 32 to 36, 36 to 40. So this would be 40, 41. So here's 42, 43, 44. So when we look at that, that would be concave up. So an angle in standard position is negative 7.2 pi. What would that be? Well, if we went backwards all the way around, that's negative 2 pi. Around again would be negative 4 pi. Negative 6 pi. Around here would be negative 7 pi. So it would be right over here in quadrant 2. Then we said let's not worry about 3 and 4. So number 5. Find the value of each of these. So negative pi is right here. That's the coordinate negative 1, 0. Sine is our y value. So it is 0. Cosine of pi over 6. Pi over 6 is in the first quadrant. What's opposite pi over 6 is half. And root 3 over 2. Cosine is our x value, so it's root 3 over 2. 5 pi over 3. Well, this is pi, or 3 pi over 3. Over here is 2 pi, or 6 pi over 3. So 5 pi over 3 is down here, with a reference angle of pi over 3. So that's negative root 3 over 2 on that side, and half. Sine is our y value, so negative root 3 over 2. 11 pi over 6, so that's almost 2 pi. So pi over 6, so opposite would be half, negative half. Root 3 over 2, so cosine is our x value. Negative 5 pi over 6. Well, this is negative 6 pi over 6, right? Because negative pi. So negative 5 pi over 6 would be right beneath that. So there's pi over 6. So we have negative half, negative root 3 over 2, and cosine is our x, so negative root 3 over 2. Negative 3 pi over 4. Well, this is negative 4 pi over 4. So negative 3 pi over 4 would be here, with pi over 4 as our reference angle. Negative root 2 over 2, negative root 2 over 2, and sine is our x value. So number 11, find the sine. So if I was to drop this down, our radius is 4. We go over 3.5 and up 1.936. So sine 1.936 over 4. Cosine 3.5 over 4. Tangent opposite over adjacent. So 1.936 over 3.5. So we could do the same thing on this one. Make your triangle, negative 0.866, negative 0.5. Our radius is 1. So sine negative 0.866 over 1, negative 0.866. Cosine negative 0.5 over 1, so negative 0.5. Tangent negative 0.866 over negative 0.5. Two negatives make a positive, and then you could divide that out. So for each problem, an angle and standard position in the xy plane, it's a given radius. A circle centered at the origin with a radius. What are the coordinates of the point? So a radius of 8 and an angle of pi over 2. Well, if we know that's 8, this is just the coordinate 0, 8. Where our next one, let's see, 3 pi over 4. So 3 pi over 4 is right here. Our radius is 22. Well, 3 pi over 4 I know, well, we could use a couple things. We could use our polar coordinates, that x equals r times the cosine of 3 pi over 4. So we could use similar to that. It turns out to be the same thing. So there's a couple ways you could go about doing this. So we know that this would be 22 times negative root 2 over 2. So that's negative 11 root 2. This would be 22 times negative root 2 over 2. So again, that's negative. That would be, oh, sorry, sign is positive. So positive 11 root 2. So you have your x and y's. The other way we could do is we could say, oh, well, I know this is pi over 4. So this is positive root 2 over 2, and this is negative root 2 over 2. But usually our radius is 1. So to get here, we have to multiply by 22. So these all have to be multiplied by 22. All right, the next one. In an xy terminal plane, it's in the position, standard intersects the circle with radius r at a given point. What are the values of theta and r? So hopefully you're seeing a lot of this repeats itself. Negative 3, oops, I'm going to put that on top, similar to what we've been doing for polar coordinates. We graph it. So how can we find our radius? Well, a squared plus b squared equals our radius squared. So this is 9 plus 9 times 3. So this is 36 equals r squared. So r equals 6. And then to find our angle, well, the tangent of that angle, negative 3 root 3 over negative 3. So that's root 3. So we have to figure out what angle has a tangent of root 3. Well, I know it's not pi over 4, so I'm going to try, is it pi over 6? Half root 3 over 2. Well, our tangent, half over root 3 over 2, keep, change, flip, is 1 over root 3. So let's see, times root 3 over root 3 is root 3 over 3. Well, what about, let's try a pi over 3. Root 3 over 2 and 1/2. So tangent root 3 over 2 divided by half. Root 3 over 2 times 2 over 1. Well, that's root 3. So I know this angle's pi over 3. But it's in the third quadrant. So this is 3 pi over 3, which is pi. So our angle has to be 4 pi over 3. So our next one, negative 7 and 0. Well, this one's a little bit easier. Our angle's pi right there. And our radius would just be 7. Okay, the function of the cosine. So let's see if we remember. Cosine starts high. And this is pi. So from pi over 2 to pi, it is decreasing and concave up. And then from pi to 3 pi over 2, so right here, it's increasing and concave up. And then we could do the same thing for the sine, except sine starts in our center. So again, right in the middle is pi. So from 0 to pi over 2, it's concave down but increasing. And from 3 pi over 2, so this part right here, to 2 pi, it's concave up and increasing. So if this is a sine, right, or sine, well, sine starts in the center. So I know it's moved down to, and what is the length of a full period here? Well, full period is 2 pi. So there's no period change. So our amplitude is 2, right? It goes up 2 and down 2. The sine of x minus 2. Where this one, what is our midline? So I know it's going to be a plus 3. But what is our period here? So a length of a wavelength is pi. So our period, 2 pi over b equals pi. So b has to be 2. So this one we would have, what is our amplitude, is just 1. So it's the sine of 2. And then I'll notice that there's a shift, right? Because sine starts in the middle going up. So it'd be x to the right minus pi over 2. So this line, our midline, 0, but our amplitude is 3. So 3, the sine. There's no shift to the middle going up. And our period, though, is 4 pi. So 2 pi over b equals 4 pi. If we solve that, b is 1/2. So we have 1/2 x. So next we have some cosines here. So cosine starts high and go low. So again, we got to check our midline is right here. So that's -3. Our amplitude is 2. There isn't a shift because it starts high. And our period is pi. So 2 pi over b equals pi. So that means b has to be 2. Our cosine starting high here. It looks like our midline is at -1 with an amplitude of 1, 2, 3, 4. And our period, so here to here is 4 pi. So 2 pi over b equals 4 pi. So it looks like this is another one where b is 1/2. So the cosine of 1/2 x. Okay, so here's a cosine. Let's see, where is our midline is about right here. So it's at 1. 1, 2, 3. So our amplitude is 3. Our period, so from here to here, well, that's 2 pi. So 2 pi over b equals 2 pi. So b is 1, but it shifted back pi over 4. So this one has to be x plus pi over 4. All right, number 27. So we have to write a sine curve with a shift. So to the right, pi over 4. So this would be the sine of x minus, pi over 7. And down 5, so -5. Let's see, a cosine, vertical shift up. So I know there's a +1. Cosine, a period between 5 times between 0 and 2 pi. So let's see. So 2 pi over b would be 2 pi divided by 5. So b is 5, so it would be 5x. So next up, we have to list all this information. So our amplitude is 2. And again, I got to factor out that pi. So this is really x minus 1. Our period, 2 pi over pi, which is 2. Our midline is at -2. Frequency, remember that's the reciprocal. So if our amplitude is 2 and our midline is -2, the high, the mid, the low is at -2. It will go up to 0 and down to -4. And our phase shift is to the right 1. So on this one, I tend to put this at the end, +4. So our amplitude is 3. Our midline is 4. Our period is 2 pi over 5. So that means our frequency is 5 over 2 pi. Our max value, well, our midline is 4. Up 3 is 7. Down 3 is 1. So it would go 7 and 1. And there's no phase shift. Okay, so we will come back to this next part on the next video.